All right, Algebra 2, folks. Today we are looking at factoring third-degree specials. I call them third-degree specials because we cannot factor all third-degree equations, only the special ones. First of all, what is a third-degree equation? Well, I shouldn't say equation. These aren't equations. These are polynomial expressions. So we're going to be factoring third-degree polynomial expressions. Third-degree polynomial expressions, the largest exponent is 3, and notice the exponents are going in descending order. Okay, except for this, we'll do it last. Okay, when we do this factoring, these third-degree specials, it's done by grouping. So we're going to do this factor by grouping. Now, so first of all, how do I know I have a third degree? Special. Anytime in my homeworks, you will always, whenever you see a third degree like this, you'll be doing this grouping technique. But for your information, I want to show you why I know it's a third degree special. Here's why. The product of the outside two numbers is equal to the product of the inside two numbers. So in other words, 2x cubed times 35 is a negative 70x cubed. The inside product here, 7x squared and a negative 10x, is a negative 70x cubed. So that's how I know that it's a third degree special. In your homework, you don't have to worry about that. You're just going to do this grouping technique. All right, now, what do I mean by this grouping technique? Well, it's not that much different than the AC technique. Remember when you guys do the AC technique, how you make 4 terms, okay? You would take your middle term and you would make a grouping of 4 pieces. So remember this right here, how you do your A times C, your 6 times 4 is 24, and you take negative 11 and you break it up into 2 terms. So now notice how we have 4 terms. And then we do the split down the middle. Well, count it out. How many terms do we have? 1, 2, 3, 4. They're in descending order. So we're going to just split down the middle. And then all I say is GCF, GCF, and we do one more round of GCF. So we have 3 GCFs and we're done. So what is the greatest common factor over here? Well, we have an x squared and an x cubed. Nothing takes care of the numbers, so we have an x squared is the greatest common factor. And then on the inside, we have 2x plus 7. Right? Now, just like in our other stuff, just like in the AC factoring, if you're confident with 2x plus 7, you better have a 2x plus 7 right here. And by the way, what goes into both a 10 and a 35? That's right, 5. Don't lose the sign, negative 5. And let's just double check. Negative 5 times 2, negative 10, negative 5 times 7, negative 35. Yeah. So we can actually do that shortcut like I showed you with the AC. Negative 35 divided by 7 is negative 5. All right, so here we go. These two are exactly the same. So that's one of your parentheses. And then we have x squared minus x squared and the minus 5 are on the outside, so that's your other parentheses. Okay? Now, the only thing that we have to worry about when we do this third degree special group factoring here is we have to look at this term right here very, very carefully. Okay? See this x squared minus 5? It looks like it's dots. Remember the difference of 2 squares? I mean, I certainly have the x squared. I got a minus sign for difference, but 5 is not a perfect square. So we cannot do any more factoring here. So this is all done factoring. This is not a dots. I usually say snots. It's not dots, it's snots. So this is done. That's all we can do. Okay. I did one on here where we have dots at the end. You'll see it. All right, let's do the next one, number 2. All right, exact same formatting. Here's our third degree polynomial special. You'll know it's a special. Even if I'm telling you to do these third degree factoring, you'll know. So all I have to do is split down the middle. All right, what's our GCF here? That's right, it's an x squared. And so on the inside, all I have is a 3x minus 1. All right, if you're confident, 3x minus 1. Negative 9 divided by negative 1 is, I can't hear you, that's right, 9. So plus 9. And if you're not sure, 9 times 3, 9 times 1. Perfect. All right. Do you want me? I can do the highlighting again like I did if you like the orange highlighter. There you go. Those two are the same. So there's one parentheses, 3x minus 1. And then, that's right, here's your other parentheses, x squared plus 9. All right, I'm going to look at this piece right here, x squared plus 9. That's right, that is not dots. That is snots, not dots, snots. We have our squared term, but it's not a difference. This cannot be factored. 9's perfect, but it's not difference, D for difference. Okay, so we cannot do any more work here. This one's all done factoring. All right, let's look at number 3. I'm going to slide this up just a little bit. All right, number 3. All right, again, do our split down the middle. All right, over here, looks a little bit more complex. What do I know about 4 and 28? Yes, no, yes, maybe? Yeah, 4 goes into 28. So we have our 4x squared on the outside. And then on the inside, what do we have? All right, that's an x. And then it's plus 7. Okay. All right, now over here. All right, there is no greatest common factor. They have nothing in common. And remember, I did this in the notes before. If they have nothing in common, then the only thing that we can pull out is a 1. We're either pulling out a 1 or a negative 1. Okay? So no. In other words, there's always a GCF. Okay? So that GCF could just be a 1. Okay? So this case has no, the only thing that we can factor out then is 1. Okay? So here we have to factor out, in this case, we're going to a negative 1. If there is no GCF, then we factor out the sign here, in this case, negative 1. And by the way, that should make sense, because if we're confident about x plus 7, over here better be an x plus 7. Okay? And the only way we're going to get that is by factoring out a negative 1. Okay. All right, I'll do the orangey again. So there's my first. Here's my second, parentheses. Alrighty. Now, what do we notice about 4x squared minus 1? Okay, there's certainly a minus sign. 4x squared is perfect. 1 is a perfect square, so this right here is dots. So since this is dots, we have to do some more factoring. Remember, dots is difference of two squares, difference of two squares. So we have more factoring to do. So 2x minus 1, 2x plus 1, and then don't lose this, so we have our x plus 7. And then now it's completely factored. Okay? So whenever you're doing these, you always have to be careful with this quadratic expression in the end. You have to make sure that it is, if it is dots, you have to do more factoring. If it's not dots, you can just leave it alone. Okay, you'll see it in the homework. All right, last two pieces that we have to do. You're going to see this in the homework as well. It's more group factoring. I know I called it wacky group factoring. the reason why I called it wacky group factoring, because we're not dealing with letters, we're not dealing with numbers, we're only dealing with letters. Okay? Now how do I know why I can just group factor this? Well, when you look at your terms, notice how I got some A's in here, a couple C's in here, there's a D here and a D there. Try your best to get it in alphabetical order. I mean, I know this is not in alphabetical order, but with the A and the D and the A and the C. But if you notice here how these two have a C's in common, these two have an A in common, so hopefully you can recognize, oh, I can just split right down the middle. Now on this side, what's your GCF? That's right, the letter A. And then I have an A minus D. Remember, you can divide everything by A. So we have A minus D. And just like when we're doing these, if we do this correctly, A minus D better be over here. All right, now it looks like, oh yeah, look at that. There's an A there, there's a D here. What do they have in common? They have a C in common. So we pull out a C, and then we have an A minus D. And here we go. These two are exactly the same. So there's one parentheses. And then here's your others, parentheses, A plus C. And that's all we can do. There's no more work to do on that. All right, let's look at my last one, number 5. Okay, my last one, number 5. We notice, are they in nice grouping pieces for us? I mean, I have a pair of P's here, but these two don't have anything in common. But if I do some rearrangings, I can make them all have something in common. I mean, I could flip-flop these two spots, so I'd have a Q and a Q and a P and a P. Okay? Or I could put this QR way on the end. Okay? So you have some room to play with here. You have some room to play. I'm looking at this, and I think I want to group these two together. I want to group those two together. And if I group these two together, this is why I'm showing you this. If I group these two together, notice I have a P squared minus PR. And what's your GCF with this P squared minus PR? Well, that's right. If I pull out a P, I have a P minus R. So then how should I write these two so I have a P minus R? This is a QR. This is a minus PQ. Which one should I write first? That's right. We'll write this one first. And I'll write the plus QR second. Guys, you have to remember, as long as we keep the operations in the correct locations, I can rearrange these things in any order I want. I'm just trying to keep things nice, neat order. Now look at this. P, 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 Q, Q. Okay? It's almost like this one up here now. A, C, C. Okay? And so obviously now we can see what we have to do on this side. Here's our split. So here we're going to factor out a Q. Here we'll factor out a Q, so I have I have to factor out a negative. Remember I said whatever the sign is? I was looking at this and I was like, what's going on here? That's right. Whatever this sign is, we have to factor out. So we're factoring out a negative Q. And then on the inside, I have my P minus R. There we go. Now they match. I was looking at it, I was like, what am I missing? Well, that's right. Whatever this sign is, we have to factor out this sign. So since this is a negative here, we have to factor out a negative. Okay. All right, here we go. P minus R, those are the same. And then we have our P minus Q. And we just factored it. All right, so we have a little wackiness and we have a little straightforward split down the middles with our group factoring, okay? So, and that group factoring is actually easier than the AC because you just split right down the middle. All right, everybody, have a good night.